Hello, everybody. Welcome to this part 19, I think. Yep, 19 of the Arduboy dev stream. There was a little pause. I was in vacation. Everything went well. And now we can continue where we were. So last time I finished the stream with a little bug, if you remember, about the crawling, about detection of the ceiling above the crawling state. So I have, after the stream, I have fixed it. So I will explain you how I did it. So yeah, first I can show you this one, the bug where it was basically here. I use double ampersand should be only one because I wanted to do a binary operation to check the collision. So after I have fixed it, replace the double quote, the double ampersand by just one, I think it works quite well. And then after I have done another commit, another change to improve that a little bit, because I face another bug that I will explain you in a minute. Also because I left you on this bug, we didn't review and commit together that change, so we can do it together. So that's for later. So where it is? Yeah, here. So if you remember, we have changed the boolean from the draw bit path extended by a int, and we were returning a bit field this time, not just a boolean value, a bit field to indicate which pixel was hit. And I used the iCall variable. I was not sure if it was the iCall variable. I should use our xcall. I think the iCall is okay. It's fine. Is what I want. So the bug was not here. This code was perfectly okay. I think I have double check it, and that's what I want. So yeah, I just changing to int, return it. So basically, this will set the bit for which column has a collision, no matter which pixels inside the column. It can be any pixels inside that column for the whole sprite, but it will tell you which column has collided. So it's a little bit more information than just one boolean saying, yeah, you got a collision. It's a little more information, more detail, and that's enough for what I wanted. So if you remember, we were trying to detect that the feet have collided, so only few column of the sprite, which is the column where the feet are. So that was enough, and yeah, we will see if we need more, but so far I think that's enough for this bug. So the header file, yeah, we just return the int, and on Rick, we have changed the draw to return an int, and I forgot why, but we will see soon. So here we had another constant value between crawl and stand to, yeah, remember it. I think it was to shift at the correct position. We added the init crawl function, which was not totally necessary, but just for the beauty of it, just to try to make it, try to make the code more maintainable for the future. We had that, so if it's looking left, we switch or not, just to keep the main character aligned, because when he's scrolling with the feet is larger, right? Okay, so here we just call the init crawl function that we created. And this one, the function to check if there was ceiling above, we have improved it, change it from checking 3 pixels. We check the full line of pixels, but you will see in the next commit I have changed again this function because it was still not good enough. So here we have the draw with the collision that I guess returned me the collision bit field, sorry. And here we were just like I said, if I collide with 0, 7, which will be the 3 last pixel which are the fit, then I have to push right or left depending on which direction the character is looking. All right, and here, yeah, we will just return the draw bitmap extended collision bit field. All right, so that works pretty well. However, like I said, I still had some issue for the function that checked the ceiling. The reason was with the statue throwing arrows. Actually, the mouth of the statue which is throwing the arrows was just on the line where I was checking if there was pixels. So when the main character was, let me show you here. So when the main character was just above, just under the statue like this, then he could stand up, because I was not detecting any pixels exactly at the position of the mouth. So you would say, okay, I could check the pixels, maybe the line under or the line above, or both pixels above and on the same line. Then that start to be maybe a lot of test, a lot of check. And if you remember what we discussed about the different strategy, about saying, okay, what we can do, we had 3 possibilities to do that. Is first, it was just checking the wall map of sprite. Directly there is collision here, which I didn't choose. The second idea was maybe draw a transparent collision sprite above the head, and this like for example would be a rectangle, just a white rectangle, fully white rectangle that we can draw above the head, and if that rectangle collide with any pixel, then I will know that there is collision above. Okay, that was the one solution, and the last solution was just checking few pixels, and we obviously have chosen that solution, but obviously this solution is not very solid, although it's maybe easier to implement, is maybe not that solid, because it depends on the sprite of the decor, the sprite of the background, actually, of the walls and everything like that. So I think the second solution to draw the sprite would have been a better and stronger solution. The first solution, checking the map data, would not be that good and that perfect, because, for example, in that situation where the main character is just under the statuette, actually the statuette use a full square of the map data, but the statue head is not is less wide than a full square. So that means if I would just check this the map data, then the main character will stay crawling, will stay in crawling state, even if I move half of the square, which means I move out of the statue. So doing a pixel collision would be, in that case, will be more precise, better. So the first solution, I think, is finally not that great. The last solution, like checking few pixels, is, like I said, is not strong enough, because like I just said, we can just fall into a hole, into black pixels, which is actually a decoration. So the stronger solution would be like the drawing a sprite and checking that whole area. But I didn't want to just create that sprite. I will maybe just like few white stuff. So I did almost the same, but I did it programmatically. So so here I will show you what I've done, and first I will show you this image I prepare for you. All right, so I just want to remind you how the frame buffer is implemented in the Arduboy API. Maybe you know, maybe you don't really know, or you don't really care, because you have the draw bitmap function, you have the draw line, you have all that stuff. So the way it is implemented in the Arduboy API, you don't really need to know. You may not care, actually. But then I will explain you. So basically, the frame buffer is just a big array of char, a big array of bytes, and there is like 8 times 228, so it's a big array of 1024 bytes. Okay, and actually one char represent one column of the screen. So basically you have 8 char per column. So the first, for example, you can understand it like that. The first 8 char of this big array is this first pixels. This first column represent the first column of the frame buffer, and then the next 8 char represent the next column, right? So, and if you zoom on one char, then you have this. Actually, they use the bit of the char, so like a bit field. Every bit of the char represents 1 pixel on the screen. So, for example, this char, like 46 in hexadecimal, represent that value 0, 1, 0, 0, etc. And yeah, basically this is how the frame buffer is stored, right? So I have implemented a new function which I call like check white pixels in row. Well, okay, it's not a very good name, but whatever. It's very hard to find good names. And what I've done here is just have a small optimization, like dividing by 8 is the equivalent of shifting by 3, but shifting is supposedly cheaper in on the CPU. But maybe the compiler already do the optimization. I'm not sure. Probably yes. So whatever. And here's the function. So I give a x, which is basically the column number, which column I'm checking, and I give a width, so on how many columns I want to check, and then I don't give a y, but I give a row number. So basically I'm giving one of these 8 rows. So this is 0, 1, 2, 3, 4, and until 7 here. I give that row. I don't give a precise x, So that means what this function will not be able to precisely check a rectangle which is in between two rows, but can check one rectangle in one row. So basically I can check, for example, I can check that rectangle here. All right, so here, if I give let me draw it with okay, so if I give it x here, and I give it the width, and I give it the row, so it will be the row number 1. This is row 1, 0, 1, 2, 3, etc. Okay, so I give on row number 1 and on x here for a width that is here, I want to check those pixels in that square, right? So remove this. So that means I just okay, start x, which is the row number multiplied by the width plus the x specified in parameters, and I iterate on the width, and then I check on inside this big buffer of 1k from start x to y, and if I detect any collision, then I set it. So I set it the same way I've set it in the draw bitmap extended, which means I return a bit field of what was collided. So obviously, again, this function doesn't work if the width is greater than 16, because there's only 16 bits in that int, but that's enough for what I need. Right, so just return that, and then in the CPP file, I just change the is there any ceiling at by calling that function, and like instead of iterating on all the line on a specific height, which was the y above, if you remember it, I just I start from start x, I divide y by 3, so which give me the row number, and with the whole sprite data, the whole sprite width without the fit, so the normal one, which is 9. So here I'm doing this approximation y. So if you remember, the main character sprite is on 2 char, is on like 12 height, but okay, the top we want to actually the y is the top of the sprite, and we want to detect the collision above the head, and the next 8 pixel is just on the second row of the sprite. So I think if we just start from the y and divide by 8, that will be the exact row that I want, more or less. So that will solve so this solution is a kind of a mix between I don't know, checking the sprite map and the map data, and checking the real pixels. So I'm just checking the real pixel, but on a specific row, which is supposed to be the row above the where the main character is when he's crawling, of course. So why is walking? It's walking because basically the row of the map are more or less aligned with the row of the screen. Not exactly, there is 2 pixels in the bottom, remember, but it's just 2 pixel shift. Okay, so except this 2 pixel shift, the row on the screen and the row in the map data are most of the time aligned. Which means that if this function will probably not work, definitely, not probably, will not work if the camera is scrolling, right? So we may expect some issue when so if we have a vertical, but I think it's not possible, but if we have a vertical change of screen, like the screen is scrolling vertically while the character is scrolling, and the player is not, it has released the down button, that means okay, the character is scrolling into a tunnel, and then the screen move up or move down. Or in that situation we may have trouble, but this situation may not happen because usually the screen scroll up and down if the characters fall, or if there is a hole, or if the character jump. For that situation to happen, we should have a tunnel and then a hole inside the tunnel so the player can fall. But anyway, so it's a very rare situation. We'll see later if this will happen or not. But yeah, so now we have a good walking crawling state. So for example, if I crawl from next to the wall like that, it's walking. I can crawl next to the wall on the other side, it's also walking. And I can also crawl when I have to put my back on the wall. So let me it's a bit difficult to place the character, but okay, maybe like this. Okay, so if I crawl, then you see that the feet has pushed the characters, and when I stand up, the character is more far from the wall. Okay, I can do it on the other side. Almost. Okay, if I crawl, yeah. So I don't traverse the wall, and I am pushed in the exact direction, in the correct direction. Oh, yeah, nice landing. Yeah, almost. Okay, and I pushed. Here it is. Okay, and for so here I'm releasing the button, and like this. On the other side, I'm releasing the button. Okay, and if I go under the statuette, so yeah, I'm releasing the button, and yeah. So we have, I think we have our crawling state walking with these successive change. So what next? Okay. So today I wanted to finish 2 states and implement a new state. First, the jump state, we need to add the jump animation, because right now it doesn't have any jump animation. That should be pretty simple. And then we can try to implement the death state. If we have time, we may start to implement the ladders. So, and that will be the last state for the main character if I didn't forget any state. So jump, death, ladder, that should be okay. All right, so death state, I already have created the frame, which is that one here, and there's only one frame, so that should be okay, I think. So it should be already here, should be already included. The sprite data we may have it. What's this called? Jump. So let's see where we should change it. So do we have a init jump? Do we have any jump? I don't think so. No, we don't have any jump. So let me check where we start to jump actually. I think it's when we are normal shape. Yeah, start a jump. Okay, that's jump. So here we should choose the jump animation ID, and when we land, maybe only this is needed. Let's try. All right, so oh no, there's the fall also. Okay, but the jump is walking. Okay, it's correctly mirror. Okay, but when I'm falling, I don't have this animation, so I also need to. Yes, I have it. What I'm saying. Okay, yeah, it's walking. No, I don't have it. Yes, it was just a walk. Yeah. Okay, so we also should set it for the fall. Which is check static collision. If there is a floor, there's no collision of the feet, so state, and we should change, the frame ID. There's no collision. Okay, so we change also to jump. Let's try again. Okay, so I didn't show you, it was here. All right, that is working. No, not this one, sorry. Okay, all right. So if I fall on the other side, okay. All right, that was pretty easy, right? Let's commit this. So we just set the correct animation frame ID. So jump and fall. I just remove, okay, my to-do list, updated my to-do list. Like I said, we have the death date to do and the climb later. Then we have the AI to do. All right. So now let's do the death date. So my idea is to do it the same way that the original game was doing it. So I mean similar way, which means make the AI or the main character like wow, jumping and falling. So to do that, we need to have the equation of the falling, the parabola equation. So you can find it into, for example, in Wikipedia or any kind of website, like the projectile motion. So basically, what we need is the displacement, which is this one here, which is the x and the y according to the time, which is v0. Let me zoom it a little bit. Yeah, which is v0t cos theta. Theta is the angle of the initial velocities. So you have an initial position and initial velocities, and then based on this, yeah, the projectile does this parabola motion, and the y, so the x basically is just like a linear movement. It's based on basically the horizontal velocity and multiplied by the time, so it's pretty easy. And the y is the same vertically, but there is this half gt square, which is g would be the gravity acceleration. So I just rewrote it in a more simple way here. Basically x equal x0, which is the initial position, plus v0 xt. So why v0 xt? Well, basically when you do v0 times cos theta or v0 sinus theta, basically it gives you the horizontal velocity and the vertical velocity, right? So you can call it the horizontal velocity or vertical velocity depending on the theta, because v0 is just a scalar value, but basically this can be, you can see it as a vectorial vector value with two components. So that would be easier for us instead of having this cos of sinus. So we have v0x multiplied by t, and or v0y multiplied by t minus half gt square, right? So this is a pretty simple equation to implement. All right, so we can just try to implement that. So first, I think we need a new state for the death. Okay, death, and then we probably here in the input, so we can do it after, like stand up, crawl, or here. Death, So when the player is dying, actually the player loses all control of the characters. So the player can we don't care about the input. We will not check the input. We'll just start to move. I will create a init death function. It will be easier. No, I don't. I will place it after here. All right. And later on we will see where we will put that. All right. So obviously the state will be death. And for the animation, I also have death animation, which are these last 3 frames here, where the player will try to move his arm like that, like flying a bit. And I think I have already declared this variable here, death start, death end. So obviously I will use the death start here, and the animation direction should be 1. Doesn't really matter because it's a loop. Is it a loop? Let me check. Oh no, it's a ping pong. It's a ping pong animation. Sorry, would be better in ping pong. All right, that should be all for now. So we will check. We will reverse the animation. Let me write the rest before. So we need a death anim speed that I will increase, that I will declare, sorry. So we increase with the current animation direction. Right, and actually inside that test we need to check if we have to reverse the animation direction. I don't want to have the first and the last frame to be played 2 times, so I can just check if that is equal. No, I'm going down. Just do it. Okay, I should check it before then. It would be easier. I will reverse the direction. So, oops, sorry. So this, if it's end or start. reverse direction if we reach the end of the loop, increase the anim frame, so just to play the animation in correct order, but again that doesn't really yeah, that matter. I want to set this in -1 finally, because I had this test before. So first time I entered this, this is death start, so I will reverse it to 1, then I will increase to the middle frame, then I go to its middle frame, so it doesn't go here, then I go to end frame, then next time it's end frame, I reverse it, and then it becomes middle frame again. That should work. So let's declare that. I have no idea. Let's put 5, maybe 3 is good also. Not sure, we'll see. So that's for the animation, and now we have to do the movement. So we will use the formula that we just that we have seen. Okay, so to do that, I need to memorize the original position. Yeah. Okay. I don't want to reuse other variables, so let's declare it. Temp state, crawl state. Okay. Variable for death state. Int death start x and death start y. I will need also some other constant value, which are velocity and the gravity, obviously, but that are constant values, so you can declare them there. Death death velocity x, so I can, again, I have no idea, let's put 5, we will tune all of them. Why? So this one, because the screen is positive downward, so I need to have a velocity negative to go up, and the gravity will be positive. So let's put it like this, and I call it half gravity. So, because if you remember, let me show you again the formula. So this one, half gravity, half g. T will be our variable, but this v0x, v0y are constant, x0 and y0 are constant, and half t is constant too, so only t will change, and x will change, x and y will change. So the half gravity, again, have no real idea. There's no, it's just about feeling. We cannot really make like normally g is 9.8 meter by second, but here as any kind of tuning value, I would say, let's say 10 for now. I don't know, we'll see. All right, and yeah, we also need, do we need a t? Do you need a time value? At least we need the start time. Yeah, so it's the same if we record the time. So let's record it. This one can be a char, I think. Death time. All right, and we can init those value when in the init death state, which I didn't declare, by the way. Let me move it here. So the start will be just the current position, and the death time will be reset it to 0, right? But we init the start x and the start y with the current value, so the main character will jump from where it is. All right, let me declare that while I'm thinking about it. We didn't call it yet because, yeah, we can also try to call it. So if you remember, it's in the checklist auto collision, and we should do this. I have to temporarily disable this, because then we will have a respawn function, a kind of respawn function. And by the way, we can also move the life counter inside the init death, right? It would make more sense. So let's move it also in that function, init death. Decrease the life counter. All right. Okay. Then we were trying to implement the trajectory of the death in the state here. So x should be equal to our death.x plus the velocity. Let me, where it is here. Multiply by the time, which I forgot the time, how we, death time, no, death time, yes. All right, so that means we have to also increase our death time for sure. This is a char. So we can, well, if we increment every, we can increment it every frame. or maybe less. So that means we could have also another on every frame like this, but probably a different speed. Or we can change this value, but if this value cannot be too low because we don't have floating point operation, so if this one is too low, then we have to decrease the pace at which the death time is increased. For now, let's just increase it like this, and we'll see. It will probably very fast. That means this one is 5 pixels, right? 5 pixels every frame. That's pretty fast, actually. Let's move it to. But I want the movement to be fast. Let's move it to 3 pixels every frame. This one could be even less, 2 pixels every frame. And this one, let's decrease it a little bit. All right. And like we said, the y will be this one, death start y plus the death velocity y minus plus, I should say, because the value already contains the minus. Yeah. Half gravity multiply by the time square. All right. So we move the main character according to a trajectory, projectile trajectory. Okay, we can just try that, and we'll try to die one time, but then I think we will have to respawn, and at the respawn state. Yeah, let's try to compile. All right. Oh, that was fast. Let's try again. That was very fast. Okay, so I think we have to, we should, yeah, we have to do that. I don't give a variable so far, I just want to test first. Like, I put a big number, like 20. I want to slow down everything first. Well, maybe that will be very slow, but we'll see. What happened? Okay. The velocity y is not strong enough according to the gravity. Let's change that. Yeah, I think maybe it should be bigger than, but if I put 10, that That's pixels, right? Yeah, we are with a lack of precision. Let's try that, but I think we will lack of precision. But that's fine. We can do something else to fix it. Oh, okay, yeah. So, oh, okay. Another issue here is like I go to the full state. So obviously we need to fix that first. So where it is, check static collision. Yeah, this one. Of course, we should not be in death state. Okay, let's try again. Oh, not this one, sorry. I miss it. You too. Okay. So we have a precision issue here, but it's doing what we want. So first let's try to reduce to the minimum that we can. So of course we'll make a very small gravity. Let's reduce that also. But I think it wouldn't be enough. Because the problem is the character is moving, yeah, is moving too much every frame. Okay. Let's increase the speed of the death time just to check. Maybe 2 times faster. All right. I still want to be faster. If I remove it totally. No, that's too fast. Very fast, actually. Okay. Okay, let's put 3, my favorite value. Maybe that's that's okay. Yeah, no. Okay. We can slow down a bit. So I will implement the respawn because it's difficult to test like that. So we will continue to tune, but the logic seems to be okay. So it's we will give another name to that death anim speed death moving speed. Right, so let's declare it. I think it's like 5 should be okay. And then increase the death timer. I just think about something. Do we have another timer that we can generalize? Would be maybe better. I think we had like frame count. Yeah, jump and fall frame count. We could reuse that one actually, which is also a timer. So I will reuse that one just to save one variable actually. Jump and fall. That's this one, okay. And init death. We can rename the variable to make it more generic. And then we increase it here, 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 here. I will just rename it like state frame counter maybe. I will just let me search it. Yeah, that's the init of the jump, the init of the fall. Yeah, and the death, and this is jump and fall. All right, so I will rename this state frame counter. Okay, I have renamed it all of them. I will just move it to some other place. For different state. A generic frame counter that can be used by different state. All right. So the respawn, we have to implement the respawn. I will create a function for that. Init respawn. it respawn. I will first I should maybe maybe just call it respawn. Yeah, I will just call it respawn. This function anyway, we will need it later because yeah, we will when the character die, we need to respawn at the beginning of the current level, not the level, but the beginning of the. Well, it depends. It's not defined if we have a check. I forgot the name. Checkpoint. Yeah, if we have checkpoint or not, or if we respawn for every screen. So if you die in the screen, respawn the screen, or if we have checkpoint, we have a checkpoint every 3 screen or whatever. So this we can define it later. But anyway, when you die, you will have to respawn to either beginning of the screen or whatever. So we can just create this respawn function, and we'll see what we'll do later. Respawn. Okay, and then I will move the function that I've commented here so far. And put it into the respawn function. So the check lethal collision becomes very simple. All right, so here temp code just teleport to hard-coded location, and I will call the init idle to reset the correct animation ID, and so and start in idle state. All right, so yeah, this check lethal collision becomes much simple like this one, I think. All right, if there is death, we just init death. And now I need to call the respawn function. So I should call it when the main character is outside of the screen. So I want to remind you again that I use X and Y as a global value across the whole map, and here I will text is X and Y against the screen. So later on we will do refactoring when we will switch the screen for converting a global value into a screen value, and we have to refactor all that code. So I know that I'm intentionally creating some potential bug for the future, but I don't want to focus too much energy on that later. I prefer to just do a path of refactoring on that later. So although I could just create a function just to prepare for the future, but let's not focus too much on that for now. So if actually I can create a function to check if it's inside the screen or not. If is on screen, we may change this function later. So if it's not on screen, then we just respawn. Right? So I'll write it here. Rick. To do translate global code to core local to the screen. So x has to be between 0 and x has to be less than width, and same for y. And y is less than height. I return this, but actually that should be x minus x plus the current the sprite width, which when we are scrolling is a bit different. So char sprite width state equal chrome then it should be cross sprite width, otherwise it's brick sprite width. Okay, so this x plus sprite width, and for the y plus same for the sprite height. So I think I can just use instead of testing it 2 times, should use a if. Oops, sorry. Scroll height. Cross sprite width. Alright, so by default it's the sprite width, sprite height. Alright, and this one here. So it will not be x, but local x, local y, but whatever. All right, so if we are not on screen, then we should respawn. Let's try that. I have error. is on screen is not declared. Yeah, actually I will move it next to those function. Where did I put it? Here, I think. After the update input. Here. All right. So, what else? Is on screen, was not declared in this scope. Yeah, I forgot the scope, sorry. This is sprite data. Scope. All right, so let's see if we have a respawn. Yeah, we have a respawn, I think. All right, we have a respawn. So now we can try to tune. I will die from here. Okay, can try to tune the speed. And the arrow is firing even if the player is dead, which maybe that could be tuned later. It's just a little bug. All right, so I want to check how long is the stream so far. 1 hour and 17 minutes. Okay. Yeah, we can I will just try to polish that, commit, and I think that will be enough for that stream. And we may do the later in the next stream. So let's polish this speed. So the gravity is at the minimum. I can clearly not make a value less than 1. It's an int. The velocity, okay. So let me think. And yeah, if I increase the speed here, how does it look? So I think I don't have enough precision. I want something less than 1, but I don't have it. Okay, that's a bit better. If I put just 1 here. Let's reduce this and this. Wow. It's too fast. Tuning 2. I don't know why it's doing 2 times. Maybe it's the arrow. Yeah. probably the arrow that is killing me 2 times. That is not so fast, but if I put 3 for the death moving speed, I'm tuning the death moving speed right now. I think it's too slow. Well, that's pretty okay. All right, so I want, so basically this value becomes too big too fast, right? But we can but I cannot decrease this frame counter actually, or actually I can, but I can increase every frame but with a smaller amount. So this I can, for example, we can divide this value by the number of like if this one is 3, currently it's 3, like every 3 I move 1, but actually I can move every frame, but I divide it by 3. So every frame this number get divided by this speed. So let's do that. So we'll not just divide it, I will just yeah, let's do a division just for okay. So why I cannot just change that, because if I reduce that value too much then it's too slow. So I want to first do the multiplication and then do the division, so I don't lose precision. So let's do that, and this should no, I think I should include both and divide it. And I just increase the frame counter every frame. All right, let's try that. Oh, that's fast. That's very fast. That's very fast. So the death moving speed is 3 so far. The frame counter increase every frame, but okay. So I will increase the value of the velocity maybe. 339. I'll divide 9. 6. Sorry, that may not be very interesting, this tuning, compared to the implementation. Okay, so yeah, no, we have a much faster, still reduced gravity to 1. But I think we're getting there. hope so. Yeah, that's much more fluid. I will increase the depth bit to 4. So if I increase it, I actually slow down. Yeah, I can slow down even more. Let's try 6. Let's start to look at something. Even more. Let's moving to 8. Okay. Okay, I think it's not too bad. 8 is not too bad. It's not jumping high enough, I think. Let's increase. So my value right now are this 8 for the moving speed, 6 and -9. So let's -12. This one can increase a bit also. The gravity is still 1. Still 1. Yeah. That looks good. All right. There's one more thing I want to do. Okay, obviously we have a bug that we are dying 2 times. I think it's the arrow killing us when okay, no, yeah. That was the bug. Now we cannot be killed 2 times by the arrow. So let's fix that bug. And then I was saying there's one more thing I would like to do is to draw the main character in invert mode when I'm dying, because I want the character to move in front of the in front of the background, in front of all the decor. So I want to draw it in invert color. So that's quite easy to do. First, let's check the bug. Check lethal collision. Of course, we should not, in the death, we should not check it if we are already dead, right? So if state is not equal to death, and we drew black, then we need death. All right. So that's the first bug. Then we cannot be killed by the arrow when we are already dying, or by anything else when we are already dying. And then, like I said, in the draw, I would like to draw in specific color. So basically I will overwrite it. Okay. If if it's scroll. I can overwrite it like that. I can just override the color actually. For the death animation, draw the main character in invert color. All right, let's try that. Ooh, doesn't work. It doesn't work. It's not invert. Let me check the API. Yep, it's invert. The color is invert. Invert. But maybe I call the draw function in different situations, so I cannot just overwrite it here. I think I have to overwrite it from the map manager here, which means I need to have I can just check the state here, or I can just create another function without parameter, which would be maybe a little better. Let's do that. Let's create no, it's not what I want to do, sorry. Let's remove that one. We make this one private. And make that one here. So we call it with the color. So I have to declare it. Color invert or white. For the normal draw, well, actually I don't need to declare a variable, I can just give it in parameter. Invert, otherwise white. Okay, let's try that. No, I need to remove that. Sorry. Okay. So it's almost not really visible, but yeah, against this one we can see that the invert color is playing this is what I want. Okay. It's not jumping high enough, by the way. So let's tune a bit more. And I think that's pretty okay, actually. Let's make it 20. Oh no, there's one more thing I wanted to do, is the jumping on the left or on the right, or making the animation on the left or on the right, depending on the, well, actually depending on from where the collision happened would be nice if it's an arrow, but that may be a bit difficult to do. So we can do it, for now we can do it based on the orientation of the player. Okay, so I'll just do that based on the orientation of the player. This is inside init depth function. This is the, oh no, it's the velocity, sorry. So it's inside the state. Here. So it's for the X. I can clean that. This side. To compute the velocity, the horizontal. So it should be, could be a char, that's enough. Velocity X. So looking left, if it's looking left, it will be negative. This one, otherwise it will be the positive value. All right. We could also have a variable that we could set in the init depth to have different horizontal velocity. For example, if I'm moving while I'm dying, then I can maybe have that velocity, or if I'm dying while I'm not moving, we can have some refinement later, but for now, let's just do that simple like that, as simple as that. Let's try it. Okay, and if I'm looking the other side, yeah, okay. Actually, I think I want to reverse it. If I look left, I want to jump on the right, just like because most of the time you if you go in that direction, you hit an AI that kill you, whatever. Yeah, I think I will reverse it. The feeling will be a bit better actually. So just reversed. If you look left, you go to the right. If you look right, you go to the left. All right. Yeah, that looks better. And if I look here, this one, I go back. Okay. Actually, as you can see, what you expect as a player is to jump in the opposite direction of the arrow, if it's the arrow that's touching you, or the AI, if you are going through AI. but it's quite difficult to know the direction of the arrow because of the collision detection that we have done. So that would be probably too much effort to implement just to have that nice feeling. We can keep it on our to-do list for later if we want, maybe if we want to improve that. But right now, I think it's probably hard to do. Yeah, compared to the jump, the death is quite fast actually, and the speed is quite linear also. I mean, you immediately start with you don't have any acceleration, so you just start with a constant velocity. All right, I think that's good enough for a first iteration of the death. Maybe I find some refinement that we could add later. So let's commit that and close the stream, finish the stream. What do we have? So just added a default draw function that is supposed to be the real draw function from the map manager, and I make the one that the color in parameters as private one. Okay, in the CPP we have quite a lot of change actually. So we have some constant value for the speed, value speed. We have the new death state. We have refractor the frame counter just to make it generic for generic usage in different state. We have our starting position for the death. We have created a respawn function in death. Okay, a function to check if the main character is on screen. And we have our private draw. In the respawn, we just teleport into idle. Okay, in the need death, we set the anim state to death, frame ID to death, and we'd increase life counter. This is just the rename of the function. We have the new update of the death state, where we update the death animation in ping pong mode. Okay, and by the way, I didn't tune the speed of the. Just let me check. That's way too fast actually. I think it's too fast. Yeah. We can decrease that value. I will tune it, make it slower. This value. Then we increase the counter. We have our two formula for the projectile parabola here, and if when the characters move outside of the screen, then we just respawn. This is the end of this death animation. Okay, this is just the rename, the function that check if it's on screen, and here in the check static collision, we check if we are not dead. Actually, we could even make this test more generic and stop checking anything when we are dead. Just have a early exit actually, because we don't need to check if there is 400 feet. We don't need to check if there is a wall collision when we are dead. So yeah, actually let me change like this. I'll change and see if it's still working good. So I remove this and I will just early exit here. Early exit when the main character is dead. We don't need to check the static collision. So early exit should be equal. If the enemy is dead, then we just skip all that code. Will be more solid, more future-proof for the bug. And also I want to decrease the enemy speed for death. 5 is too fast. Let's put 8 maybe. Alright, let's try again. That I didn't break anything. Alright, seems to work again. Okay. Right. So, and the animation speed is, it's difficult to see actually, because I'm moving so fast. Well, okay, anyway, I will tune it later. That's fine. Let's go back to this. Let's reload it. So, here we were here, so if we are dead, we just don't do anything. In the lethal collision, this is the init death, and we have our draw, which override the white color. We choose with white or invert color depending if we are dead or not. Yep, that's it. And I think that's the only one. Okay, so implement the death state for the main character. All right, let's commit it. That's good. Okay, so thank you for following this Arduboy dev stream. Like I said, next stream we will probably finish the behavior of the main characters, like the ladders, how to climb the ladders. And I think that will be done. It will be done for the main characters. So that would be great to have a fully functional character. After that, we can start working on the AI. And after that, we can start working on the screen transition and the respawn stuff and all that stuff. And once we have all that, we can start building some level. And then we will add more funny stuff like music, sound, and stuff like that. So thank you for following, and see you in the next for the next time, for the next stream. Bye bye.